This video is going to take a look at ways to model a couple of different cul-de-sacs with OpenRoads Designer. The Office of CAD and Mapping had received a request from a district user looking for some guidance, and I had put together a rough video to provide the user with some ideas, and I thought I could improve upon it and make it available to everyone. So we're going to take a look at two different examples, a standard cul-de-sac and an offset cul-de-sac. There are some assumptions being made that you are familiar with the basics of OpenRoads Designer, horizontal vertical geometry tools, creating and modifying a corridor, as well as creating and using a linear template and a surface template. I've already created a couple corridors and templates that we're going to use. And if we take a look at my template library, I have a simple roadway section, a shoulder section with some end conditions for my linear template, as well as a basic pavement build-up section for my surface template. So let's get started. I'm going to go ahead and slide my view to the right, where I have two new corridors already started waiting for us here. The first thing I need to do is create a center point for my cul-de-sac. And what I'm going to do is use the geometry point command to place the center point. So one thing to note is when I do this, the Ohio DOT standard did not have a great feature definition to be used for something like this, and that could be a possibility to add in the future. Maybe some sort of scratch point that's going to be visible. But so I'm going to leave this set as no feature definition for now, and then if I take a look at my active symbology, I'm going to make this something that I can see easily in my view. So I'm going to make it a color of 4 and let's say a weight of 8 or maybe even 10 would be easiest to see. My elevation mode is going to be set to plan element. That way my point will come in at the elevation of the profile along my center line. So I'm going to go ahead and locate my plan element. My elevation offset is going to be 0, and then I need the data point where I want this to be, so I will snap to the end of my line. And now you see I have a yellow circle in both my plan and my 3D view. So now we're going to go ahead and use this center point to go ahead and create the edge of pavement for our cul-de-sac. And using my feature definition toggle bar, I'm just going to go ahead and set my active feature definition to the edge of pavement feature definition. And now I'm going to go ahead and use an arc between points, and I'm going to set my placement method is going to be a center and a radius, and my radius value is going to be 50. So I'm going to go ahead and accept these prompts, and I'm going to just pick 2 points and go ahead and create the back part of my cul-de-sac here. Next, what I'm going to do then is use a arc between elements, and I'm just going to place a 50 foot radius to connect the two, from the edge of pavement from my corridor and the cul-de-sac edge of pavement that I just created. And I only want to trim the ahead element here. I want to leave my corridor alone. So I'll create this on each side, and it'll automatically trim back the extra from my cul-de-sac edge of pavement. Now what I'm going to do is I'm going to take and just pull back my template drop for my corridor to the beginning of these first radius here. So now we have it's a little bit cleaner for us to work with here. Now we need to go ahead and define profiles for these 3 elements that we just created. So I'm going to go ahead and start with the back part of the cul-de-sac, and I'm going to open a profile view for it. Although we don't really need to, but I just wanted to show what's going to happen when we use the define a profile by a point from or by slope from a point command. So when I do that, I'm going to define the profile of this point, and I need to select the point from the 3D view now. And I'm going to use negative 1.6% slope. So a profile is created and it's automatically set to active in my 3D view. Next, we'll create a profile for sort of the radius returns that we created. And then I'm going to use the profile intersection point command to have the edge of pavement of our roadway and the edge of pavement of the cul-de-sac defined in my profile view, and then we'll connect the points to create an active profile for that edge of pavement. So one point is placed here, and then I select the other, and now I have 2 points here. Now I'm just going to use a line between points and connect the dots. And then I'll make this profile active. And while we're here, it should be worth noting that this is meant to be an example. The geometry that you may have could be different. This is not a design standard by any means. It's just to show the concept of modeling a cul-de-sac. So your profiles that you define, you may end up having to create with vertical curves, maybe to provide a low point, especially if you have some curb and gutter section going through there. You may need to define something better for drainage and those sort of situations. So moving on, we'll go ahead and do the exact same thing on the opposite side. And again, I'll locate these 2 points. And set this one active as well. Okay, now I have the basics of my cul-de-sac, but I do want to also create one other additional piece of geometry, and to do that I'm going to set my feature definition to scratch 2. And I want to create an element here across the edge of pavement, and this is because when we create our terrain for our proposed pavement, we need something to close this boundary off, otherwise it's going to follow the center line back to the beginning. So I'm just going to snap to the 2 edge of pavement points, and then I'll open a profile view for it. And then I'm going to use the same profile creation command with profile intersection points, and I'm going to locate the edge of pavement, my center line, and the other edge of pavement. And then I'll use a complex by PI profile to connect these dots, and then set this as active as well. So when you use the scratch element or the scratch feature definition, it's a little bit difficult to see, especially in your 3D view, what elements you have here. So one little trick you can do is if you go to your Home tab and you go to Manage your element templates, which is what the feature definition pulls from. And if I look at the Scratch 2 element template, it's just all set to the standard bi-level symbology. So if I change this maybe to red and maybe a weight of 4, so I can see it, we can see in our 3D view that has changed. Just a little bit easier for us to see, as well as in the plan view, it's also changed. And now we're ready to go ahead and create a terrain of our pavement surface, and then apply our surface template to that to add our pavement build up to apply the depth to it. So we will start by going to terrain and use the create from elements command. And my feature type is going to be set to boundary, and my edge method will be none. I also want to set my feature definition to proposed pavement surface. And then I'm just going to go ahead and select the 4 elements that we just created. And notice I get a couple contours here, but I still need to add in the break line. My center line is a break line to make the contours appear more like what you would expect to see here. So I'm going to go to Feature Management, I'll add a feature. And from my 3D view, I'm going to select my terrain, and then I'll select the center line to add as my break line. And now you'll see those contours appear much more like what you would expect. So we're almost done now. Next thing we want to do is go ahead and go to modeling detailing, and I want to apply a surface template here just to give this to apply the pavement buildup to the terrain that we just created. So I'm going to use the cul-de-sac surface template in my template library I showed earlier, and from my 3D view I'm going to select my terrain and then just data point through the prompts, and now you can see a pavement buildup was applied here. The last thing to do to finish this cul-de-sac out is apply a linear template to each one of these edge of pavement elements that will apply the shoulder and the grading end conditions to these pieces here. So there you have a simple way to model a standard cul-de-sac. So now let's go ahead and just take a look at the offset cul-de-sac. So I'll slide down to my other corridor here. And the concepts are the same in this case, except what I wanted to show was how to create a little bit of extra geometry needed to create the offset cul-de-sac, or that you're going to need to also create the surface template or surface terrain. So by doing that, I'm going to keep my feature definition set to Scratch 2, and I'm going to go to my Geometry tab. And what I want to do is create a line from an element. And I've already populated the dimensions that I'm going to need here. So what I'm going to do is select my center line, and my offset is 0. And I'm just going to, I don't really care where I start at this point. You may have a point that you want to start this at. This is going to be where the center is perpendicular to the center line. So you may be able to use Civil AccuDraw to locate your exact starting point. I'm just going to data point a point here, and I want it to go to the south, so 270 degrees here, and I want it to be an offset of 38 feet. Now I'm going to place an arc between points, and I want to set my method here to start and end, pass through. And then I'm going to snap to the end of this line, and I'm going to work backwards. And my radius value here is going to be 143 feet. And then my end point, I'm going to use a tangent snap, make my end point tangent to my center line. And then I'll data point through to place that. And the reason I did that this way is that if I wanted to move the center point of my cul-de-sac, I can pick this geometry up and just move it wherever I need it to go. And then this point, or this arc that we created, is going to turn into our break line. And that would move with it as well. So now we need to do is go ahead and apply a profile to each one of these elements. So I'm going to select this offset line here, and I'm going to do the same thing I did previously. I'm going to use the profile intersection point to come up with the elevation at my center line. And that point's created in my profile view. Then I'm going to create a line, and I am going to toggle on my Civil AccuDraw here. I'm going to create a line beginning at that point, and I'm going to do it by a slope. So my end station is going to be 0 plus 38, and I want this to be negative 1.6%. So then we'll set this active, and we'll create a profile now for our arced element here. And again, I'm going to use the profile intersection point to create my centerline point as well as my offset point. Oops. set this active as well. And then the last thing we can do to create our center point is use the point command. And again, this is set to no feature definition. And I want to set this at the end of that center line. So now I have my center point that I'm going to use to create. That point will then be used to create the profile for the cul-de-sac element, or the edge of pavement element. Now I'm going to go ahead and create the edge of pavement components or elements here. So I'm going to set my feature definition back to the edge of pavement, and I'm going to use the same commands I used previously. I'll do an arc between points. Again, I need to change my method back to center radius, and my radius value I'll set to 50. And then I'm just going to snap to the center point. I'll just pick 2 points to create this. And then I'll do an arc between, a simple arc between elements. And again, I'll use a 50-foot radius here. Select my edge of pavement from my corridor, and then select the cul-de-sac edge of pavement. And I'll trim the ahead part of it. Now what I'm going to do is move back the corridor to the beginning of this radius, which leaves us one more edge of pavement component that we need to go ahead and place. So what I'll do here is I'm going to use a single offset partial, and my offset value is going to be 12 feet, the same as the lane. I'll select my center line, I'll select my begin point, and I'm just going to extend it beyond the cul-de-sac there. Then what I can do is go to the drawing tab, and I can just use the microstation, extend the elements or trim the elements, and trim those two together. Then I'll also just go ahead and create the last piece that we needed to create our boundary for our surface terrain. Okay, so now we have our horizontal geometry all created. I've started a profile for my boundary point there, and now let's go ahead and profile the edge of pavement elements. And I'm going to go ahead and set my feature definition back to edge of pavement. And then I'll use, again, you're going to use the define profile by slope from a point. And I need to select my point from the 3D view. And again, I'll use a negative 1.6%. Now I can do the same thing here. Okay, now that we have all of our edge of pavements and our break lines are profiled, we can go ahead and create our surface terrain. So we'll go to terrain, create, and go to from elements, and we'll select the edge of pavement and our boundary line here. Again, feature definition is set to pavement surface, and my feature type is set to boundary. So now you see a couple contours were created, but we need to go ahead and add in this last arc as our break line. So we'll add a feature, select our terrain, and then locate the break line. So there our contours look nice and smooth like we would expect. And then to finish the rest of this out, we will apply our surface template for our pavement buildup, and then apply a linear template for the remaining elements for our shoulder and our grading. So there you have the basics of modeling and offset cul-de-sac. That concludes this video. If you have any questions or need some assistance, feel free to submit a support request to the Office of CAD and Mapping. Thanks for watching.